All right, so over here I have from your notes, this is on the arithmetic sequence. This right here would be, which we didn't point out, this is a formula that you could use to always write the explicit formula for an arithmetic sequence. We did point out for the geometric sequence that, hey, this will always be something that you can use. And in either of these cases, A is our first term. And so we're going to use that on this problem now for constructing sequences. They tell us the second and fifth terms of a sequence are 3 and 24 respectively. They want us to find an explicit and a recursive formula for both of these cases. So A is going to be arithmetic. Now, the tricky thing with this is they didn't tell us the first term. They told us the second term. They didn't tell us the third or fourth, but they did tell us the fifth. So for arithmetic, I'm going to start off by saying, well, I know it has to follow this general rule that the nth term is the first term plus n minus 1 times d. But I don't actually know any of those letters right now, like any of my variables. I do, however, know what that I have a2, right? I have the second term, so it equals the first term plus 2 minus 1 times d. And actually we can say a2 is 3. The second term is 3, so that equals a1. 2 minus 1 is 1, so that's just a1 plus d. Then I can do this again, thinking about the fifth term, that a5 equals our first term plus n minus 1, so 5 minus 1 times d. The fifth term is actually 24. We still don't know the first term, but then we can do 5 minus 1 is 4d. Now we have a system of equations that we can solve, which may seem a little weird to you. Excuse me. But I'm going to multiply this equation by -1 so that I can eliminate my a's. So -3 equals -a1 minus d. So that's 21 equals 3d. Divide by 3. And you get d equals 7. So that's the common difference, and I can plug back in like over here to get a1, because 3 equals a1 plus 7, so subtract 7 over, and you get a1 equals -4. So both of these things now help me write the explicit formula, so that's a of n equals -4 plus n minus 1 times d, which is 7. Okay, that's just taken straight from this right here. The recursive formula, we need to know what a1 is. It's -4. Then every element after that comes from a of n minus 1 plus our common difference, which is 7. So the first one is explicit, the second one is recursive. Now let's do it for a geometric sequence. So this time, I know that an equals a1 times r to the n minus 1. So they told me what the second term was. So I would plug in 2 minus 1. Well, that's going to give me 1. A of 2 is 3. So this is 1. So r to the first means that I just have a1 times r. Now I would do it with a5. Okay, so this is supposed to be 5 minus 1. And a of 5 is 24 equals a of 1 r to the 4th. If we solve this for solve this for a1, then we get 3 over r. We're going to plug that in over here. So r to the 4th over r gives us r cubed. So that means we have 24 equals 3r cubed. Divide both sides by 3. 8 equals r cubed. Cube root both sides tells us r equals 2. So then we just have to go back and plug in, for example, over here. If I put a 2 right here where this r is, that means a of 1 equals 3 over 2. So 3 halves is a1. And now I can write our two formulas. A of n equals our first term, which is 3/2, times 2 to the n minus 1. And then recursively, a1 is 3/2. an equals our term in front of that, times 2. Timesing by 2 every single time. So there you have it.